Hello everyone, I am Adya from Sri Venkateswara College of Engineering from Department of CSE. Today me and my friends are going to give you all a presentation on wine quality prediction. The team members are myself Adya A, C Disha, Bhargav BS, Geetashri V and Chandana S. Contents: Introduction to Wine Quality Prediction, Overview of the Wine Dataset, Exploratory Data Analysis of the Wine Dataset, Pre-processing Steps for Wine Quality Prediction, Feature Selection and Engineering for Wine Quality Prediction, Selection of Machine Learning Algorithms for Wine Quality Prediction, Model training and evaluation for wine quality prediction, performance metrics for evaluating wine quality prediction models, challenges and limitations of wine quality prediction, conclusion and future directions. Introduction to Wine Quality Prediction. Welcome to our comprehensive guide on predicting wine quality using machine learning techniques. The journey from grape to glass is complex and each step in the process can profoundly affect the final quality of wine. Viticultors and winemakers alike strive to perfect their craft, but at times the relationship between the variables at play and quality outcome can be exclusive. Herein, we seek to demystify this connection using predictive modeling against a backdrop of rich data. Accompanied by modern machine learning algorithms and exploratory data analysis, we explore how one can access and predict the subtleties of wine through qualitative means. This presentation walks you through the every data sets that capture wine's essence, drives into the vital pre-processing steps, and elucidates the features that matter most. We navigate through algorithm selection, model training, and the careful evaluation of performance metrics, all while considering the inherent challenges of such complex predictive tasks.
My topic is overview of the wine dataset. The foundation of wine quality prediction lies in dataset itself, which typically encompasses physiochemical tests and sensory data. These datasets often include parameters such as acidity, sugar content, alcohol level, and other compounds that are scientifically linked to the wine taste and fragrance. So here is the um, what do you call that features which we have been used in our dataset, and description and data type of those features. Fixed acidity, umbrella term for all known volatile acids. So the data type is numeric. Volatile acidity, amount of acidic acid, citric acid found in small quantities can add freshness. Residual sugar, so sugar remaining after fermentation. Chlorides, amount of salt, free sulfur dioxide prevents microbial growth and oxidation. Total sulfur dioxide, amount of free and bound forms of SO2. Density, the density of the wine. pH, measures acidity on the scale of 0 to 14. Sulfates, wine additive that can contribute to sulfur dioxide gas levels. Alcohol, percentage of alcohol content, and finally the quality, which is our output variable. And all the features or attribute which is being used in our data set is of the data type numeric. Exploratory data analysis of the wine data set. Before delving into predictive modeling, it is necessary to perform EDA. It means exploratory data analysis, to understand the underlying structure and behavior of the wine dataset. It helps in identifying the patterns, removing the unusual data or null data from the data sets, and it also helps in establishing relationship between variables. So there are three characteristics um, which preserved Okay. Uh, okay, there are three characteristics which may influence the perceived quality of the wine. Distribution analysis, correlation matrix, and outlier inspection are the three characteristics. Distribution analysis, assessing the spread and shape of each feature to understand the data and data's normality and to identify potential skews that affect the model. Correlation matrix, evaluating how variables interact with each other, which involves understanding whether they move in tandem or in if one is a strong predictor of another. Outlier inspection, also identifying the data points that deviate significantly from the norm, which might signify the data entry errors or true anomalies worth investigating.
Pre-processing steps for wine quality prediction. Pre-processing data is an imperative step to prepare an effective machine learning algorithm. Cleaning the data, dealing with the missing values, normalizing scale features, and encoding the variables are a part of this stage. Pre-processing involves several steps such as data cleaning, which means cleaning of the inconsistent values or removing it from the dataset in order to maintain the data integrity. Handling the missing values involves filling or discarding the empty records, and which would be crucial for further prediction processes. Feature scaling, normalizing data to ensure no variable would dominate the other variable on the basis of the scale differences. Categorical encoding means transforming the non-numeric values into the numeric values for enabling further computations. Feature selection and engineering for wine quality prediction. Feature selection and engineering are pivotal for enhancing the performance of the predictive models. This step involves choosing the most informative features and creating the new ones that can better capture the complexities of the wine quality. Techniques such as principal component analysis for dimensionality reduction or the creation of the interaction terms might be the important to maximize the predictive power of the model. Steps involving such as dimensionality reduction, which involves reducing the number of variables under consideration so that we can improve the model performance. Interaction terms, engineering new features that represent the interaction between two or more variables which might have combined effect on the wine quality. Variable importance, utilizing the techniques such as feature importance to identify which variable contributes for the predicting the target.
Selection of machine learning algorithms for wine quality prediction. Selecting the right machine learning algorithm is crucial for building effective models for wine quality prediction. We consider a wide array of algorithms to find one that best fits our dataset. The decision is typically informed by the nature of the dataset, the computational complexity, interpretability of the model, and the accuracy of predictions. Decision trees, useful for the interpretability and handling of nonlinear relationships. Neural networks, powerful at modeling complex, high-dimensional data with intricate patterns. SVM, effective for datasets with clear margins of separation between the quality levels. Model training and evaluation for wine quality prediction. Model training involves using the wine dataset to teach a machine learning algorithm how to predict wine quality. Once the model is trained, it is critically evaluated using a separate testing set to ensure its accuracy and robustness. During training, parameters are tuned and the model learns to discern patterns that correlate with quality. Evaluation helps in measuring its predictive power. Data splitting, dividing the dataset into training and testing subsets to validate the model's performance on unseen data. Parameter tuning, optimizing the algorithm's hyperparameters to balance the bias variance trade-off and improve model accuracy. Model evaluation, using metrics like accuracy, precision, and recall to assess the effectiveness of the model on the test set.
performance metrics for evaluating wine quality prediction models. Different performance metrics offers insights into various aspects of a predictive model's effectiveness. These metrics helps in understanding not just accuracy but also the model's ability to generalize, its precision and its reliability. The careful examination of these metrics is fundamental for fine-tuning models and ultimately impacts the decision-making process when deploying the model in real-world scenario. 95% accuracy, the proportion of total prediction that are correct. 0.89 AUC, the model's ability to distinguish between classes. 92% of precision, the fraction of correct positive predictions. Challenges and limitations of wine quality prediction. While the potential of machine learning in wine quality prediction is immense, these are significant challenges and limitations. These include the subjectivity of taste, variability in the data due to environmental factors, and the potential for overfitting complex models. Maintaining a balance between a model's complexity and its interpredictability is also a delicate endeavor. That practitioners must navigate through skillfully. Subjectivity. The subjective nature of wine tasting means the quality is not an absolute but perceived differently by individuals. Variability. Environmental factors such as soil, climate, and year to year variation introduce inconsistency in the data. Complexity. The risk of developing overfit models that perform well on training data but poorly generalize to new data. Balance. The art of selecting the right level of model complexity that is both accurate and interpredictability.
Key steps in data preparation and initial analysis involve importing necessary libraries, loading the dataset, checking for null values, performing data analysis, and splitting the dataset. Importing libraries includes tools for data manipulation, visualization, and machine learning algorithms. Loading the dataset provides the foundation for predictive modeling containing attributes like acidity levels and quality ratings. Checking for null values ensures data integrity, while data analysis uncovers patterns and relationships using visualization techniques. Feature selection identifies relevant attributes, while splitting the dataset into training and testing sets ensures model generalization. Various machine learning algorithms, including logistic regression, decision trees, random forest, support vector machines, K nearest neighbors, Gaussian navy bias, and XGBoost are utilized for wine quality prediction. Each algorithm has specific strengths suitable for different types of data and problem scenarios. Linear regression predicts wine quality as a continuous numerical value, highlighting how each input feature contributes to overall quality. Decision trees offer interpretability and capture nonlinear relationships, making them valuable for exploratory analysis. Random forests improve prediction accuracy by combining decision trees and identifying feature importance. SVMs are effective for classification tasks with complex decision boundaries, while KNN calculates quality based on similarity to neighboring samples. Gaussian navy bias models conditional probability distributions efficiently, and XGBoost provides high accuracy with regularization techniques. These algorithms offer diverse approaches to predicting wine quality. Conclusion and future directions. We have navigated through the multifaceted process of wine quality prediction, touching upon the various stages from initial data set overview to model evaluation. The importance of meticulous data analysis, pre-processing, and the strategic selection of features and algorithms cannot be overstated. Going forward, the inclusion of more diverse data sets with richer sensory profiles and the harnessing of emerging machine learning techniques like deep learning offers promising avenues for even more nuanced predictions. Moreover, cross disciplinary approaches which incorporate domain knowledge from viticulture and enology will continue to improve the quality and utility of predictive models in this domain. Thank you so much for watching our presentation. If you liked our presentation, please do like, share and subscribe.